So we're interested in finding the derivative of hyperbolic cotangent. dx of hyperbolic cotangent. Cotangent hyperbolic of x. What is this? So first of all, remember the definition of hyperbolic cotangent. Hyperbolic cotangent is defined as hyperbolic cosine divided by hyperbolic sine. So let's just write this guy down in nicer format. Hyperbolic sine, which by definition is equal to, you have e to power x plus e to power minus x divided by e to power x minus e to power minus x. But remember that both of these have denominator 2, they cancel out, okay? So let's just plug that in here and apply the quotient rule. E to the x plus e to power minus x divided by e to the x minus e to power minus x, the derivative. And again, remember that if you have f divided by g prime, it is f prime g minus f g prime divided by g squared. So this guy can be written as e to the x plus e to power minus x derivative times e to the x minus e to power minus x minus, don't forget the subtraction, e to power x minus e to power minus x derivative times e to the x plus e to power minus x, and all is divided by the denominator to the second power, e to the x minus e to power minus x to the second power. Now we just need to take the derivative, apply algebra, simplify as much as we can, so we can find the derivative of hyperbolic cotangent. This in turn can be written as e to the x minus e to power minus x, let's close this up, times e to the x minus e to power minus x minus, and the derivative of e to the x is just e to the x, minus, now you have the derivative of e to power minus x, which is minus e to power minus x, close up the parenthesis, times e to the x plus e to power minus x, and divide everything by your denominator, which is e to the x minus e to power minus x to the second power. Perfect. So let us move this up a little bit so we have enough space. This in turn is e to the x minus e to power minus x times e to the x minus e to power minus x minus e to the x plus e to power minus x, and then e to the x plus e to power minus x. Okay. And don't forget the denominator. Very good. So let us do a little bit of algebra. Distribute e to the x into parentheses. What do we get? We get e to 2x, and then minus e to the x times e to power minus x, then distribute minus e to power minus x into parentheses. Later, we simplify the whole thing. So you have minus e to power minus x times e to power x plus e to power minus 2x. You have a subtraction to the same thing on the other side. So distribute e to the power x into parentheses, then distribute e to power minus x into parentheses, and then simplify. So here we go. We have a negative sign. We can distribute this negative sign here as well. Minus e to power 2x minus e to the power x times e to power minus x, and then minus e to power minus x times e to power x minus e to power minus 2x, and divide everything by e to the x minus e to power minus x to the second power. As you remember from algebra, if you combine these two, it becomes e to power x minus x, or e to power 0 or 1. So this guy is 1, this guy is also 1, this is 1, this is another 1. So at this point, you can simplify this further as well. Why is that? E to power 2x minus e to power 2x, they get canceled out. And here you have e to power negative 2x and minus e to power negative 2x. These two get canceled out as well. So what's left? We're left with negative 4 divided by e to the x minus e to power minus x to the second power can be written as negative 1 divided by e to the x minus e to power minus x to the second power over 4. In terms, it can be written as negative 1 divided by e to the x minus e to power minus x divided by 2, the whole quantity raised to second power. But what is e to the x minus e to power minus x, all right? Isn't that the hyperbolic sign? That is correct. So you have negative 1 divided by hyperbolic sign of x to the second power, which in turns can be written as negative 1 over hyperbolic sign to the second power, or minus 1 divided by hyperbolic sign, as you remember, is hyperbolic cosecant of x to the second power. So you can simplify this to minus hyperbolic cosecant to the second power of x. So let's go back up. What we tried to do, we tried to find the derivative of cotangent. The derivative of cotangent is negative hyperbolic cosecant to the second power. Negative hyperbolic cosecant of x to the second power. And these are the steps behind them. Move this guy. Not a good idea. Let me just go back. Okay. Perfect.